This data sufficiency question, once you strip away the details, is an inequality question, right? Is the units digit greater than 5? In general, for inequality data sufficiency questions, it's usually a good idea to think about extreme scenarios. So the most extreme scenario I can think of for units digits is the units digit of 0. Can the units digit be 0 for these two 3-digit numbers? Yeah, I can't see why not. And as long as you keep that option in mind, I think it's fairly easy to show that neither statement is sufficient on its own. Because if one of the units digit is 4 and the other is 0, well, that's a no, right? The units digit would just be 0, which is not greater than 5. But if you wanted to get a yes and get a product that is greater than 5, you just take 4 and 2. Similarly, for statement 2, if one of the units digit is 7, well, the other one could be 0, which would again lead to a no, or it could be 1, which would get you a yes. So I think that's the easiest way to kind of prove that neither statement is sufficient on its own. Now, when we combine the statements, we know everything we could possibly want to know in order to find the units digit of the product. I actually explain in my book the reasoning behind why all of the other digits can be ignored when all we care about is the units digit. You can just look at the units digit of each of the two numbers, multiply those together. In this case, that would be 7 times 4 is 28. So 8 is the units digit of the product. That, of course, is sufficient to answer the question, and therefore the correct answer is C. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.